Hello out there, welcome to this tutorial on integral calculus. In this video, we'll be looking at integration by part. This is part 2 on integration by part. Check the description section of this video on our YouTube channel to get the link to part 1 and other parts. So we have our problem here. Integrate integral of x squared e raised to power x dx. By integration by part, we have our formula integral of u dv is equal to uv minus integral of v du. So what we'll do is to assign one of this to be u and the other one to be dv. The one we are going to assign to be u is the one that can easily vanish after several differentiation. We now look at the other one to be dv. If you look at x squared, the first derivative of x squared will give you 2x. The second derivative will give you 2. Therefore, we are going to assign this to be u, and then e raised to power x dx now will be dv, because that one can be easily integrated to get our v. So we go ahead to say dv is equal to e raised to power x dx, and then our u will be equal to x squared. Integrating this, we have integral of dv equal to integral of e raised to power x dx. Integral of dv gives v, and integral of e raised to power x dx gives e raised to power x. We then differentiate this. Du dx is equal to 2x, and then we are interested in du. So we make du the subject of the formula. We have du to be equal to 2x dx. We then go ahead to substitute into the main integral, which is integral of x squared e raised to power x dx. So here our u is x squared, so we have a x squared. Our v is e raised to power x, so we have x squared e raised to power x, then minus integral of our v. Our v is e raised to power x, and our du is 2x dx. So we have 2x dx. We rearrange this and bring this constant outside the integral, so that we now have x squared e raised to power x minus 2 integral of, we are left with x e raised to power x then dx. So if you look at this now, this is forming another integration by part. So we are going to integrate x e raised to power x dx using integration by part again. So at this point, our u is x and our dv will be e raised to power x dx. So we have dv to be e raised to power x dx and our u to be equal to x. Integrating the first part, the integral of dv is v. Integral of e raised to power x is e raised to power x, and since the u dx is going to give us 1, so making the u the subject of the formula, we now have the u to be equal to the x. We then go ahead to substitute into the formula to get the integral of x e raised to power x dx. Our u is x and our v is e raised to power x, so we have it as x e raised to power x minus integral of v. Our v is e raised to power x, and our du is equal to dx. So we can easily integrate this, so that we now have x e raised to power x minus the integral of e raised to power x dx is e raised to power x. Then we add the constant of integration to be c. We go ahead now to substitute this, the integral of this, into this component. Remember, we are going to multiply by 2, so that integral of x squared e raised to power x dx is equal to x squared e raised to power x. So we are going to use this minus 2 to multiply the whole of this. Minus 2 times x e raised to power x will give us minus 2x e raised to power x. Minus 2 times minus e raised to power x will give us plus 2 e raised to power x, then plus our constant of integration. So this is the final solution for the integral of the function integral of x squared e raised to the power x dx. And this is the end of solution to this problem, and this is where we are ending this tutorial. I hope you enjoyed it. Thank you for watching. Please like and share this video. Also check the description section of this video on our YouTube channel to get the link to other videos on integral calculus. Until we come your way again, goodbye.